Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
This video is about question from May June 2012, paper 41, question 1b. So the question wants us to list the measurement that we would need to make using this apparatus in order to calculate the enthalpy change of formation of magnesium oxide. So how we could actually make use of these measurements in getting enthalpy change of formation for magnesium oxide is that, first of all, we calculate the heat absorbed or released from the reaction by using mc delta T. So where m here actually is the mass use of the water. So therefore here, one of the measurements to get from this apparatus is mass of water use for the M. So next, C is actually specific heat of capacity of water, where we can get it from data booklet first page, which is 4.18. And next, delta T actually is temperature change. So in order to get temperature change, we could actually measure the temperature in this apparatus to get initial temperature and final temperature. To calculate temperature change. So next, the next step to go is actually we make use of the Q that we got in joule and convert it to kilojoule to calculate delta H. So where we have Q in kilojoule over the number of mole of the reactant. So where in this case, we have actually magnesium ribbon. So it will be the mass of magnesium ribbon used. So we need to get this measurement in order to calculate mole of magnesium ribbon used. The next to go is part C. So the question wants us to calculate enthalpy change of formation for magnesium oxide, making use of given information and also some data from data booklet. So we could actually construct a Born-Haber cycle in order to get this value. So to construct a Born-Haber cycle, we could actually start with the element to form magnesium oxide. So where we have magnesium solid plus half O2 gas, because we just need one oxygen. So then here we'll have arrow down for enthalpy change of formation for magnesium oxide. So this is the product of the reaction. So next to go, we could actually start with enthalpy change of atomization of magnesium, where since the value is positive, which is an endothermic reaction, so the arrow will be pointing up. So for atomization of magnesium, we will turn magnesium solid to magnesium gas So since we do nothing to oxygen, so we just write it back for the oxygen. So and for this process to go, the enthalpy change is positive 148. So after this, we'll go for ionization energy of magnesium. So where we are turning magnesium gas into magnesium 2 plus gas by releasing 2 electrons, and there's nothing changed to oxygen. So for this process to go, we got to get the data from data booklet since it is not provided. So we could actually get the first ionization energy for magnesium, which is positive 736, plus the second ionization energy of magnesium, which is 1450. So this process actually includes the first ionization energy and the second ionization energy of magnesium. So in order to turn magnesium into magnesium 2 plus ions. So after done with magnesium, then we got to atomize oxygen. So we just copy back from magnesium 2 plus gas. And for this step to go, we are actually turning O2 into gaseous atom. So this process is actually atomization of oxygen, where the value or the enthalpy change is not provided here in the question, but we could actually get it from data booklet, where atomization actually it's half of bond energy. So we could actually get the bond energy for oxygen from data booklet, which is 4, 9, 6. So for the atomization, we're going to divide this bond energy by 2. So done with atomization, the next step to go will be turning O oxygen atom gas into O2 minus. So O2 minus actually involves 2 electronegativity, where we have the first electronegativity and the second electronegativity. So we could actually combine 2 of these processes into 1. So where when we sum them up, we actually get positive 657. So since it is positive, so we could actually make use of arrow up to show it is an endothermic reaction. To turn oxygen into O2 minus. So this process actually is gaining 2 electrons. So therefore, the electron is taken or absorbed by oxygen atom to turn into O2 minus gas. So this process involves first electronegativity and second electronegativity of oxygen. So the last process to go is actually the lattice energy. So why it is arrowed down is because lattice energy is an exothermic reaction. So for this process to go, it involves negative 3791. So with this Born-Haber cycle, we could actually calculate the enthalpy change of formation for magnesium oxide. So where the working will be in this way. So we have enthalpy of formation as our unknown. So for this value to go, it is actually equals to the sum of all these reactions. So where we have here positive 148 for atomization of magnesium, plus first ionization energy and second ionization energy of magnesium, followed by atomization of oxygen, which is half of bond energy, plus first electron affinity of oxygen and second electron affinity of oxygen, and lastly we have lattice energy of magnesium oxide. So with this calculation, we could actually get the enthalpy change of formation of magnesium oxide with the answer -552 kilojoule per mole.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.